Consortium for Data Science, DataBytes lunchtime webinar series. Today's speaker, James Guszcza, is the U.S. Chief Data Scientist at Deloitte Consulting, and he'll be talking with us about using big data, small data, and behavioral insights to make better decisions. During the course of his career, Jim has applied statistical and machine learning methods to diverse business problems such as healthcare utilization, talent management, customer and employee retention, insurance pricing, fraud detection, and much more. Jim has also explored the use of nudge tactics to more effectively act on model indications. Today's talk will last about 30 or 40 minutes or so, roughly, with time for Q&A at the end, written Q&A. And feel free to type questions in the chat box as we go along, and we'll hold all questions until the end of the presentation. Thank you very much, and Jim, welcome, and thank you for agreeing to make this presentation today.
Thank you, and it's my pleasure. So everybody on the phone, thanks for dedicating your lunch hour to this webinar, and for those of you like me who are on the West Coast, I hope this will get your day off to an interesting start. So yeah, I've been at Deloitte for about since 2001. I'm currently the Chief Data Scientist here, and my background is actuarial science, and I've gotten a lot of experience in a lot of different domains since then. And about 10 years ago and counting, I started making the connection between the predictive modeling work I'd been doing for several years, both at Deloitte, my previous employer, which is Allstate, and behavioral economics, and more recently I call it behavioral science. And these two quotes kind of are the most articulate quotes I've found that kind of sum up the way I've come to think about the work that I do here at Deloitte and many of my colleagues do here at Deloitte, and in the business analytics world more generally. So the first quote is by, the famous Richard Thaler, the author of this great new book, Misbehaving, and Cass Sunstein. These guys together wrote the book Nudge back in 2008, which has sort of become the playbook of the global behavioral insights movement, big revolutionary movement in public policy. And this actually came out 4 years before Nudge came out. This is a review they wrote of Michael Lewis's original book, Moneyball. They wrote this back in 2003, I think. And, in the course of this review, they wrote, why do professional baseball executives, many of whom have spent their lives in the game, make so many colossal mistakes? It takes time and effort to switch from simple intuitions to careful assessments of evidence. I mean, this is a very significant quote coming from someone like Richard Thaler, writing at the University of Chicago Business School, which is sort of the Vatican of free market thinking. Because these guys are saying there really are inefficient markets out there. And they're kind of making the suggestion in this review of Moneyball that what's at root here is kind of cognitive biases of human decision makers. So it's a very, very interesting set of connections. The first part of my talk is going to kind of unpack that quote. The second quote will come later in my talk, and that's by not a behavioral scientist, but he's a very entertaining speaker and very insightful guy, Rory Sutherland, who's a creative VP or creative director at Ogilvy Mather. And Rory Sutherland wrote, many programs and services are designed not for the brains of humans, but of Vulcans. Thanks in large part to Kahneman and his many collaborators and pupils and acolytes, this can and will change. And I think Rory Sutherland's comment is sort of like a complementary set of, it points to a complementary set of ideas to predictive modeling and business analytics. So for me, the two overdue sciences are using data, experiments, predictive models, machine learning to help people make better decisions in the business world. The second set of ideas are using nudge tactics to help drive the behavior change that very often is necessary, pointed to by those models. So I'll unpack both those quotes in the course of this talk. That's the theme. So those are the themes. So the first is analyzing analytics. I want to talk about the kind of playing Moneyball. Along the way, I'll make some comments about big data that I hope people find interesting, and then I'll turn to the second set of ideas about using nudge tactics to act properly on predictive model indications. So analyzing analytics. So yeah, so it all goes back to Moneyball, and what's interesting about this story, and of course, just to refresh everybody's memory, I think most people know this story, but Michael Lewis broke this very, very interesting story about how a cash-poor baseball team, the Oakland A's, was able to win in an unfair game. That was the subtitle of Michael Lewis's original book. And what win in an unfair game really means is use data to do well, profit in an inefficient market. In this case, the market was a market for talent, and the market was inefficient in the quite literal sense that the price of an asset did not reflect all the publicly available information about the asset. That was the whole point of the book. There's all sorts of data being collected about baseball players, we knew how to analyze the data thanks to the work of Bill James and Sabermetrics, but no one is acting on it. It's a Billy Bean to actually act on that data. That was the drama of the movie Moneyball. So you know, an inefficient market persisted and still persists in a lot of domains because of an unwillingness to kind of like go beyond just using gut feel, professional judgment, you know, which are infused with, you know, a raft of cognitive biases and actually make the time and effort it takes to act on evidence and data. When Michael Lewis wrote the book, he didn't realize it, but he's really kind of tapping into a body of research that had been going on in psychology since the 1950s. That guy down there in the lower left-hand corner of the screen, he looks like Colonel Sanders. There was a very eminent psychology professor named Paul Meehl, M-E-E-H-L, who's at the University of Minnesota. And he devoted his life, actually created a field of study called clinical versus actuarial judgment. These guys, and Robin Dawes is another one, these guys studied decisions in just about every conceivable domain. Doctors making triage decisions in an emergency room, psychologists making diagnoses, you know, university admissions officer making admissions decisions, you know, HR officers who are using interviews to make hiring decisions, and so on and so on. And what they found is that in every single case, human intuition would be outperformed by even a very simple regression model, okay? So that was called clinical versus actuarial judgment. And so Moneyball is actually another case study you can add to this list of case studies that Paul Meehl and Robin Dawes and their fellows came up with. And what's interesting is that in Thinking Fast and Slow, Daniel Kahneman, who later shed a lot of insight in Paul Meehl's work, said that when he was a young guy, Paul Meehl was a huge influence to him. He was actually a hero to Daniel Kahneman in his early days. So the roots of business analytics go back a long way in the psychology literature. To illustrate what I'm talking about the cognitive biases that can lead to inefficient decisions and inefficient markets, stop me if you've heard this one, but think about this. This is kind of audience participation here, all right? There's a little experiment. Think about this person who I'm going to describe. Her name is Linda, and Linda's 31 years old. She's single and outspoken, and she's very bright. She majored in philosophy in university. As a student, she was deeply concerned with issues of discrimination and social justice, and she also participated in anti-nuclear demonstrations. Okay, so that's obviously a dated example, but now you can say she participated in the Occupy movement. Now, you formed a mental image of Linda. Now I want you to, you know, think about this question. Which is more likely, that Linda's working as a bank teller right now, or that Linda's working as a bank teller and she's also active in the feminist movement? Don't think, blink. What do you think is more, well, what would your judgment be? So Daniel Kahneman and his collaborator Amos Tversky, the late Amos Tversky, posed exactly that question to a group of university students at Berkeley and Stanford. And what they found was that 87% of the people who they asked thought that being a feminist bank teller was the more likely scenario than being a bank teller. So it's more likely that Linda's a feminist bank teller. Now, these are Berkeley and Stanford students. These are smart people. But that answer is logically impossible because the set of bank tellers, the set of feminist bank tellers is a subset of the set of bank tellers. So it can't possibly be the case that it's more likely that Linda's a feminist bank teller. Yet there's this little man jumping up and down inside our brain saying, no, it's more likely that Linda's a feminist bank teller. So that's a small, easy example of how telling ourselves stories, you know, to arrive at a conclusion or make a judgment, it makes all sorts of sense. We're very confident in those stories, but sometimes they just don't hold water. Another example, which is completely different, and this is a more recent example, real life stuff. A group of people studied the decisions of judges making parole decisions. Okay, these are judges in Israel, although that's neither here nor there, and they studied the decisions of many judges over many weeks, and they just plotted the rate of judges granting the people parole throughout the day. And what they found was that at 9 o'clock in the morning, if someone's up for parole, that person has about a 60% chance of being granted parole, and that probably shrinks down to about 0 at about 10:30 in the morning, and then at 10:45 it spikes up to about 60% again, and then shrinks down again, and then after lunch it spikes up again. And the implication of this finding is that the judge's level of blood sugar actually affects their parole decision. Okay, so you know it takes physical energy, not just mental energy, but it takes physical energy to make one of these kinds of decisions. So these are two of many dozens of stories that get repeated. These are easily replicable experiments that have been conducted hundreds and hundreds of times. And Daniel Kahneman summed up this body of research that he's devoted his life to studying. He's the Nobel Prize winning psychologist Daniel Kahneman, won the Nobel Prize in economics in 2003, I think, despite the fact that he's a psychologist, not an economist. And so Daniel Kahneman summed it up this way. So there are two types of mental operations. There's thinking fast and thinking slow, or we call it type 1 and type 2. Type 1 thinking fast, is automatic, effortless, and makes associative sense. It's associatively coherent or narratively coherent. Type 2 thinking, or thinking slow, is more like actuarial judgment. It's controlled, effortful, but it's logically coherent. And the implication of that Israeli judge story is that actually, when we say effortful, we really mean effortful. It takes physical energy to make tough decisions. And very often what we do is we substitute hard decisions for easy decisions, and we make decisions not based on some kind of like an intuitive analysis of evidence. We don't survey the data, say how complete is this data, what are the indications of that data, how sure are we about those indications like a statistician would do. No, we just tell a story. And our confidence in that story is a function of how clear the story is in our head, how narratively coherent it is, has nothing to do with its logical coherence, or very little to do with its logical coherence. And the rub is that most of our mental operations are type 1 in nature. We just have we have limited bandwidth. So, so when we make decisions as we go throughout the day, we use a lot of kind of mental rules of thumb to make those decisions, like as in the Linda example. And it turns out that those mental heuristics are systematically biased. So this is called heuristics and biases. In other words, thinking fast, type 1 thinking has a lot of trouble with statistics. So that's kind of a fascinating kind of ethical discovery that we didn't know, before 30 years ago, is that the human mind is systematically biased. Dan Ariely calls it predictable irrationality, right? It's not just that, Jim's wrong and his friend Joe is wrong, but they're both wrong in opposite ways, and their kind of errors will cancel out, so the wisdom of crowds will always work. No, it's their systematic biases. All right, this is predictable. In his new book, Misbehaving, which everybody should read, Richard Daley said that when he first read one of those papers by Daniel Kahneman, when they talk about systematic biases, it's almost like his hands were shaking because he knew that his research would never be the same again. That's a very, very important discovery. And it's exactly what lies behind, in my opinion, the success or the importance of a lot of predictive modeling work, okay? And so, the implication is that these kinds of what I call actuarial models are everywhere, right? I've used these in the early part of my career, literally in actuarial science. I mean, so I've used predictive models to help insurance underwriters evaluate which risks are likely to be profitable versus unprofitable. And of course, we all know that's done for, say, motor insurance. You can almost just like build an algorithm that kind of comes up with an automatic rate for car insurance. But what about insuring a business for their workers' compensation liability or their, or their general business liability? How would you do that? You don't have as much data, and the risks are all very different in nature. And so, traditionally what happens is you have an insurance underwriter visiting the business, and they'll make a judgment call. They'll have a checklist of things to go through, and they'll say, okay, I say, yeah, let's insure this business, and I like it so much I'll give it a discount off the base premium. Well, that's a lot like, Moneyball. That's exactly like Moneyball, in fact. And what we found is that regression models, they don't replace underwriters any more than a regression model would replace an emergency room doctor. But what we find is that an underwriter using the regression model outperforms the underwriters using professional judgment in exactly the same way that a baseball scout using data analysis or predictive models, the fruits of data analysis will outperform an underwriter just using Linda-type judgments. And these things are all over the place. The 2012 re-election campaign, that was called the first big data election because both the Obama and Romney campaigns used data to try to predict which voters were persuadable. Whose door should you knock on? I think HR analytics is a huge wave of the future. It's just like Moneyball. It's still not being exploited as much as it should be. Using data to help make hiring decisions rather than just using interviews and kind of gut feel of the people conducting the interviews. That's a huge area of the future of analytics, I think. We've built models to predict which doctors are the highest risk of being sued for malpractice for patient safety and risk management reasons, and so on and so on. One very interesting application was we're able to use lifestyle data to predict the likelihood of lifestyle diseases. So in addition to family history and genetics, just the digital exhaustive, the way people live their lives is predictive of healthcare utilization and even comorbidities. So yeah, this stuff shows up everywhere. And it's not just because it's big data. There's an interesting story here. All this stuff goes into the guise of big data these days. But what's interesting about a lot of these applications is that the data's not always big. If you're building a predictive model for an insurance company and they're insuring businesses, well, think about how many businesses are there in the country. And what if it's a regional insurance company? There's no doubt that if you build a predictive model for that insurance company to help guide its underwriting and pricing decisions, that will be, there's no doubt about it. If you build it properly, act on it properly, that will improve your loss ratio, will improve your bottom line. But it's not because of big data per se. The data is not big in this formal sense of high volume, velocity, and variety. It's big relative to what people used to do. So in this kind of colloquial sense, it's big data. But, you know, really it's because the data is being used to kind of counterbalance human limitations, what are called flaws in probabilistic reasoning. So there's this great quote that kind of telegraphs the idea by Richard Nisbett, who's coming out with a new book, actually. He's one of the top psychologists in the country. Nisbett and Ross wrote, human judges are not merely worse than optimal regression equations. They're worse than almost any regression equation. So you can think of, so this sort of like alternate story to the big data story. It's not just because the data is big in various senses of the word. It's because the alternative to using regression models is so bad. It's the limitations in human cognition. Okay, so whether the data is big or not is sort of tangential in some ways. But I'll have more to say about big data as we go along. And as we go on, here's actually another example from a book called Big Data. This just to give you an idea of how innovative this stuff can be. This really is no different in principle than the other examples I've given, but it's a very clear example of what's colloquially called big data in action, but really it's clinical versus actuarial judgment, or it's playing Moneyball in public sector. So how did the Bloomberg administration play Moneyball in the domain of building safety? Well, New York City has a lot of old buildings, and so they have a cadre of building inspectors. Traditionally, the building inspectors would use procedures to visit certain buildings. Maybe somebody called in and said, hey, this building looks dangerous, broken windows, somebody's going to break their neck. So they'll send out a building inspector, and if the building warrants it, the building inspector will issue a vacate order. Now, traditionally, 1 out of every 10 visits, such visits will result in a vacate order. So the Bloomberg administration hired a data czar. I think his name was Jim Flowers, I think. And the data czar led a team of data scientists, and they built probably a regression model, some kind of a predictive model. And the regression model basically assigned a probability or a score to each building in New York City. And you're able to rank all the buildings in order of their likelihood of needing a vacate order. And so rather than just using the traditional procedures to deploy their limited resource of building inspectors, they used the predictive model to deploy those resources. And after they did that, instead of 1 out of every 10 visits resulting in a vacate order, 7 out of every 10 visits resulted in a vacate order. So it's a huge uptick in profitability, or I'm sorry, in efficiency. So profitability in the private sector, efficiency, being able to do more with less, serve the public better in the public sector. So it's a great application of big data. And it's a very socially responsible application of big data because you're doing more with less, you're saving money, and you're making the city safer. So you can't argue with applications like this. What's interesting is that it's called big data, but it's no more big data than those actuarial examples. And in fact, the author of this, the guy who broke the story, Ken Cukier, is the data editor for The Economist magazine. It's been a wonderful story. He asked me, Jim, isn't this what actuaries do when they're pricing homeowners risks? And I said, that's exactly right. And so this, I've come to think of this as being the city of New York doing actuarial science. So it's using, it's an example of innovation, taking ideas that have been used in one domain. Now we're using it in an innovative way in a new domain. It's very, very exciting. So analytics can definitely be a sort of seedbed of innovation. I was actually thinking about, I live in California. I live in Santa Monica, California, and I was driving up to Santa Barbara a few months ago, a couple of days after Governor Brown announced mandatory water restrictions in California. And I thought, couldn't the state of California do something similar is what the city of New York did? I don't know if the state is doing this or not, but if not, they should be perhaps using data to figure out what parts of the water supply chain are the low-hanging fruit. Could you easily remediate these? Also, worth to say about nudge tactics in the context of this story as well later on, but that's my dry idea. Another example of how data can be used in an innovative way, and this sort of goes a little bit beyond the Moneyball actuarial versus clinical judgment story, although it is related. There's this great quote from William Goldman. He's the guy who wrote the script to The Princess Bride, and he wrote the script for Butch Cassidy and the Sundance Kid. He's this legendary Hollywood figure, and he wrote this memoir called Adventures in the Screen Trade. And this famous quote from this book was, "In Hollywood, nobody knows anything." He kept repeating it throughout the book. Now, people think that he was just slamming all the Hollywood executives for being these money-grubbing people who don't understand art. That really wasn't what he was saying. He was just saying that the world's a really complicated place, and you don't know how the movie's going to do when you release it. You could have this brilliant movie starring Robert Redford with Robert Towne writing the screenplay or whatever, or me writing the screenplay, but we just don't know how it's going to do. There's just too much randomness out there. The error term in that regression model is too big. But what's interesting is that, the world has changed since William Goldman wrote that book. And, Netflix might be a perfect counterexample of what Goldman was saying. It might have been true back then, but it's not quite as true now. There's this very nice story about how when people were pitching the idea of a TV series called House of Cards, the story was that Netflix really leapt on it. They really picked it up, and they didn't just say, "Oh, okay, maybe this works. Let's do a pilot and test the pilot." They actually hired 2 seasons worth of episodes all at once, and they sunk a lot of money into it, which is a very unusual decision to make. But they made that decision in the light of data analysis. See, what's happening is that now we're in this age when people aren't just simply renting a movie and then that's all you know. Maybe you record that, maybe you don't. They actually know, that Jim is binge watching Downton Abbey over a whole weekend, but he turned off Game of Thrones after two hours. And so they know these very, very detailed things about the customer's viewing behaviors. Okay, so the amount of data we leave behind when we're doing something very commonplace like watch a movie is much different than in the old days when we'd just attend a movie screening or rent a movie from Blockbuster or something. Now we really know exactly what people are watching. We can make associations between people's habits. And so what Netflix was able to ascertain was that by analyzing these large stores of data was that people who watch Kevin Spacey movies tend to watch a lot of Kevin Spacey movies. They also tend to watch a lot of movies directed by David Fincher, who's the director for The Social Network, and he's also on the creative team for House of Cards. And so, that was what was being pitched, was that, they had a solid core group of Kevin Spacey, David Fincher viewers. But not only that, they actually found that a subset of those Kevin Spacey, David Fincher viewers had binge-watched an old BBC miniseries called House of Cards. House of Cards is a remake. And so Netflix was able to analyze this vast store of data they had because people were leaving behind these digital breadcrumbs as they were viewing the movies. And they're able to use that data to make this very lucrative business decision, which is to produce House of Cards. And that actually went on to become a major success for Netflix, won Emmy Awards, and arguably it helped change Netflix's business model from distribution to actual production of movies. So that goes a little bit beyond the Moneyball story. This is an example of how data can actually be used in innovative ways to change business models. So that's very exciting. To me, that's the true sense of big data. That's the sense in which, quote unquote, big data is an important topic of discussion. So while we're on the subject of big data, I can't resist to say a few things about this. Another great example of big data in action, this is a poster child, this is in Ken Cookie's book, is Google Flu Trends. I mean, if Google search data isn't big data, nothing is. It is certainly high volume, velocity, and variety. It's not just structured data, it's unstructured data. It's free-form text being typed in every day. And the folks at Google, who are very innovative people, they have very enlightened HR policies, and they have 20% time, and they allow their employees to brainstorm, and it's very, very laudatory. Somebody had a really smart idea. They said, the CDC, the Centers for Disease Controls, they have their time series models that kind of track flu outbreaks. I'll bet we can track flu outbreaks just as accurately and faster than the CDC does because we know what people are typing. So if there's an uptick in people searching for words like flu, cough, sick, doctor in Des Moines, Iowa, well, that probably means there's a flu outbreak just about to happen in Des Moines, Iowa. So we have our finger on the pulse of the nation. We can track flus better than the CDC traditional models can. And that was I'm speaking genuinely, a very, very clever idea. It was written up in Science magazine, which is one of the top science journals in the world. Great breakthrough, and it's a poster child for big data. And this algorithm worked really well. I mean, you can see from this image here that the Google algorithm was tracking, the CDC predictions very well, and it was giving us faster indications. It was a completely new data source. And it kept working well until it didn't. At some point in 2011, it started greatly over-predicting the outbreaks of flus. Okay, and this was actually, this is actually analyzed. This episode was analyzed in a study that came out again in Science magazine in early 2014. The second article was called "The Parable of Google Flu: Traps in Big Data Analysis." And this kind of illustrates a certain danger in thinking too naively about big data. There's this kind of idea that people have. This is the sense in which big data doesn't make sense to me. There's this idea people have that once data gets beyond a certain threshold, it's sort of like there's a phase change happens, like an ice cube freezing. The data becomes so big, it's so complete, that you can just throw traditional science out the window. In fact, there was an old article written in Wired magazine by Chris Anderson, the editor, and the title was something like, "Google proves that the scientific method is outdated." Okay, and it was also a theme of the book Big Data, is that once the gist was that n is equal to all. Once n, the size of our data, is equal to all, once we have all the data, things are different all of a sudden. And the lesson of this is, well, maybe things aren't so different after all, okay? Because like, what was going on here was that the idea was smart. The algorithm did make sense. What happened was it was just a big data approach. It was just a machine learning approach. They weren't really paying a lot of attention to the process generating the data, which is, after all, people's search behaviors. Now, Google, because of its core business, is always updating its search algorithms. And so, so the data coming from searches is changing. The ratios, the proportion of the word flu in proportion to all the searches, that changes over time. But the algorithm wasn't changed to track those changes in the process generating the data, and that's kind of what went wrong here. And the point is certainly not to say on Google. The point is more to say, hey, if it can happen with Google, with something this prominent, it can happen anywhere. And so what you want to avoid is this idea of big data hubris. This is sort of the David Lazar and his co-authors. This was their diagnosis. They said big data hubris is the often implicit assumption that big data are a substitute for, rather than supplement to, traditional data collection and analysis. That's the sense of big data that I think we need to stamp out. We don't need a big data revolution, we need an all data revolution. That was kind of how they concluded their article, and I heartily agree with that. Very often, as we saw in the Moneyball examples, you don't need data that's big in this formal sense to have business value, quite the contrary. And the other side of the coin is, even when you do have big data, you can't throw traditional methodology out the window, okay? But still, as that Netflix example, suggested, there's something new in the world here. Big data is a tagline for something new and important, right? The world changed since William Goldman was writing his book, Adventures in the Screen Trade. Here's the way I think about it, and I'm fortunate that this tracks my earliest example as a data scientist back in 1999. No, I'm not so old that I invented credit scoring in 1960, but we've known this since the early 60s, that credit data is very predictive of who's going to default in their mortgages. That's why credit scores, have been invented and are used regularly to set interest rates and determine who's going to get a mortgage. In 30 years, so that was the first non-military use of supercomputers, I believe. I believe that idea came from the Stanford Research Institute in Menlo Park, California. And the guys who invented that idea, their last names were Fair and Isaac. It took over 30 years for the insurance industry to take that data and learn that credit data is also hugely predictive of who's going to crash their car. This is an early example that I had. I literally built a credit scoring model using the same methodology that's used for banks, or very similar methodology. I was doing it for an insurance company, and what I saw firsthand was that credit data wasn't just mildly correlated with who's going to crash their car. It's actually much more predictive than a lot of traditional actuarial rating factors for car insurance or homeowners insurance. It's not just predictive, it's one of the top 3 or 4 or 5 actuarial predictors for personal auto insurance. So it's massively predictive. Progressive Insurance Company pioneered this, but once they rolled out credit score, the other insurance companies had no choice. They had to follow suit and develop their own credit algorithms. Otherwise, it'd be adversely selected against. And this seemed a little mysterious at the time. Like, why on earth would credit predict who's going to crash their car? Because there's no obvious causal correlation, right? You can imagine a causal correlation in the banking world. If you don't pay your credit card bills, you're not going to pay your mortgage bills, fine. But crash your car? Really? So the way, back when I was doing this, the way I thought about this was, well, okay, it's probably the case that people who, are overstretched emotionally, or they have limited attention or limited resources, or their lives are just strapped in one way or another, or maybe they're just risk-seeking individuals, those people are probably more likely to have poor credit, and they're probably also more likely to have more car crashes. They're probably also, maybe they're a little bit less careful, they're a little bit less in control when they're driving. So there's a common hidden correlation. So maybe it's the case that credit is an outwardly observable proxy for an abiding behavioral trait that in turn causes car crashes. I think that's exactly what's going on. And so when I was doing this analysis, I thought, well, what if we could use, what if we could somehow get our hands on supermarket club card data, scanner data from a supermarket? That's typically used, to do cross elasticities and do promotions and, send coupons and set prices and things like that. But maybe you could use that same data for something else. Maybe the people buying green tea and health food, and they buy copies of Martha Stewart Living, maybe they'll have fewer car crashes and fewer homeowners claims. And maybe the people who buy, big bottles of, cheap beer and junk food and, Motor Trend magazine, maybe those people have more car crashes and more homeowners claims. Speculation, but 10 years later, I was actually able to test that hypothesis. I actually did work for a supermarket in a different country in Europe that had a club card scheme. And what I found, this is what we did, we found that we were able to use that supermarket club card data to predict who's going to crash their car, who's going to have a condo insurance claim, who's going to have a renter's claim, or who's going to have a homeowner's claim. So it's, again, not quite as predictive as credit, but very predictive in a very similar way. Now, what's interesting about these are old examples, right? So credit data goes back to the early 60s. Marketing professors started studying supermarket scanner data in the mid-90s, I think. Now, fast forward to today, everything we do is digitally mediated. Not everything, but much, much more of what we do is digitally mediated. Watching movies is digitally mediated. Calling a friend, texting a friend, posting, liking something on social media, booking a hotel room in Bali. What is your political opinion? What are you reading? Do you finish the book or do you stop reading the book at a certain page? Amazon actually tracks that sort of thing. What websites are you visiting? All this stuff. These are all digital breadcrumbs we leave behind, that leave behind these traces. And as the credit scoring examples illustrate, the supermarket scanner data with insurance examples illustrate, this stuff can be used in ways that are very powerful and ways that were not initially anticipated. So it's very exciting and maybe a little scary at the same time. So, I came across this quote from Sandy Pentland a few years ago, and I just thought it was beautiful. It completely resonated with me. Is so articulate. Sandy Pentland is a very, very brilliant professor at MIT Media Lab. He wrote a book called Social Physics, which is fascinating. He said, I believe that the power of big data is information about people's behavior instead of information about their beliefs. So it's not about the things you post online or the survey responses you give, which is what most people think about. And it's not data from internal company processes and RFID tags. The sort of big data he's talking about comes from things like location data off your cell phone or credit card. It's the little data breadcrumbs you leave behind as you move around the world. These breadcrumbs tell the story of your life. Big data is increasingly about real behavior, and by analyzing this sort of data, scientists can tell an enormous amount about you. They can tell whether you're the sort of person who will pay back their loans, and they can tell you if you're likely to get diabetes. Okay, and literally we've used some of the same data, as I said earlier, to predict just these things: loans, car crashes, disease states, healthcare utilization, who's going to make a good employee, and so on. So this is the sense in which big data is real, okay, is that it's digital breadcrumbs and it's behavioral data. So Sandy Pentland, he has a phrase that he coined called reality mining. He's not doing data mining, he's doing reality mining. He's saying these digital breadcrumbs are, reflections of behavior, okay? It's just like, it's sort of like in auto insurance, right? Now we have black box devices attached to cars that collect telematics data. It's reality mining. It's not just credit being a proxy for your driving behavior, it's your driving behavior, and it can in principle be collected in great, great detail. Who's accelerating when? We could even in principle track who's accelerating in a school district and so on. So we're in the era of reality mining. And to really drive this point home, example that I came to a couple of years ago when I was researching an article on social responsible uses of big data, because that's obviously an important topic now. Researchers at Cambridge University Psychometric Center, a guy named David Stillwell has led these efforts, built a predictive model of personal details based purely on social network likes. So what they had is they had a sample of about 60,000 data points, one for each person. These were all American citizens, all of whom had posted or had disliked various bits of social content. I like Lady Gaga, I like Downton Abbey, I like House of Cards, okay, I like Obama, whatever it is. And they also had some personal characteristics of these people for whom they had like information. So they knew whether they're married or divorced, whether they were substance abusers, they knew whether they were Democrat or Republican, whether they were Christian or Muslim, whether they were gay or straight, whether they were black or white. They knew all these things, and they were able to predict all of those things, in many cases with 80 or 90% accuracy, just based on a sparse data set of Facebook likes. Because you can imagine this is very sparse data. I mean, most people don't have a like for Lady Gaga, but some people will. So they were able to analyze those likes in precisely the way that psychometricians analyze surveys, like at eHarmony or when you're getting a personality test. They used those exact same techniques, and they were able to infer all these characteristics of people. They were even able to come up with a pretty good proxy for one of the big 5 personality traits of openness to new experiences. So just this one data source, which you wouldn't think of as being mined for any particular purpose, was actually rich enough that you were actually able to construct a pretty good proxy for one of the big 5 personality traits and predict all sorts of personal details. So I think the guys who were doing this were, kind of like trying to point out the kind of societal implications of all this stuff, but it's also an illustration of what Sandy Pentland was saying, which is that these digital breadcrumbs are hugely predictive. because they're behavioral traces that we leave behind. And so later on in that conversation, Pentland issued the warning. Since this data is mostly about people, there are enormous issues about privacy, data ownership, and data control. You can imagine using big data to make a world that's incredibly invasive, incredibly big brother. George Orwell wasn't creative enough when he wrote 1984. So yeah, I would echo that, and I believe that these issues of data ownership, corporate social responsibility, they should really be part and parcel of the dialogue around the use of this kind of data going forward. So there's some examples like playing Moneyball, predicting which buildings need inspections, you know, doing a better job of underwriting auto risks. You know, these are just smart things to do. It's just smart business. It's kind of like, you know, in some cases, they actually make the world a safer place. So fine. But in other cases, you can imagine this data being used in very good, very innovative ways to help keep people healthier, more prosperous, to help businesses run better, and so on. But you want to be careful because you don't want to create a world that nobody wants to live in at the same time. So that's sort of the place we're perched at right now. So look, the first two parts of my talk, I talked about playing Moneyball, and I've gotten into this idea of big data, which I think really is behavioral data. You know, maybe a smarter way of framing our conversations. Instead of focusing on the size and volume of data and the variety of data, maybe we should focus on the behavioral content of data. That might be a more useful organizing principle for strategic conversations about how should we use data. The last connection I want to make is kind of a different connection. It's an independent, it's a second connection between behavioral science and data science. Just to repeat, the first connection was that, you know, behavioral economics, well, you know, all of Daniel Kahneman's discoveries about limitations in type 1 thinking, the fact that fast thinking is bad at statistics, that explains the power of business analytics in many, many domains. And it also explains why business analytics can provide huge ROI, even when the data is not big in the formal sense. It's only big in the metaphorical sense. The second connection I want to make is acting on model indications, okay? So you can kind of paraphrase this idea of actuarial versus clinical prediction or playing Moneyball is intelligence augmentation, right? So in the same way that I'm myopic, and so I go to the ophthalmologist, he gives me a set of glasses, I put the glasses on, I can see better. Well, predictive models help people think better. They're mind tools in a certain sense, okay? It's like a prosthesis that you can use to make better estimates, judgments, predictions, forecasts, and so on, okay? So we've gone through all that. And acting on those model indications is, in principle, straightforward, although in practice, there are a lot of subtleties, and it's in some ways the hardest part of the whole process is figuring out how to, you know, change your business processes, you know, to reflect the indications of predictive models. It's not a trivial thing, but in principle, it's straightforward. It's all economics. So if the model tells you that Jim is a risky driver, don't insure him. Just don't sell him insurance. Or if you want to sell him insurance, or if you have to sell him insurance, set the rates accordingly. If the model tells you that Jim is likely to be a poor employee, don't hire him, and so on and so on. So the last mile problem is just kind of acting sensibly. But what if it's a different kind of application? What if the predictive model is saying that Jim is in good health now, but if Jim doesn't change his behaviors, he's likely to become obese 5 years from now? That's what we predict based on his lifestyle and where he lives and his family history and so on. Or what if Jim is already an employee, but this predictive model indicates that he's likely to become less engaged and maybe even quit the company in 6 months if we don't intervene? What do you do about those cases? There's no economic principle that can be invoked. It's not all just about like offering more money or just making an economic decision. No, the goal is to change behavior. You want to change Jim's eating behavior, or you want to change his behavior at work. So we don't just need intelligence augmentation to help us kind of weigh the numbers better to come up with better prediction. We also need behavior augmentation. We need to know how to change the behavior that's indicated as being needed by the model. So that's what I call the last mile problem. So how can we, once the model points us in a certain direction, to a certain case, to a certain person, how do we promote safer behaviors? How do we increase customer loyalty or employee engagement? How can we promote better diet and exercise choices, better patient compliance, improve financial responsibility? Those are all examples of the last mile problem. And what I'm claiming here is that this sort of new emerging science of behavioral insights is a wellspring of ideas that can help us go that last mile. So the point I'm making is that data science and behavioral science are sort of two complementary parts of a greater whole. the motivating example for this is literally how I thought of this idea, was reading the papers after the 2012 election. I'd certainly been following both the Obama's and Romney's campaign's use of models. I alluded earlier to the Obama's campaign's use of uplift models to predict which voters are persuadable. So they didn't try to predict who's the hardcore Obama voter, because you don't want to bother knocking on their door. You might actually make it less likely to vote. You might turn them, you might upset them by bothering them. You don't want to kind of flag the likely Romney voter, because again, if they're a hardcore Romney voter, they're probably not going to be persuadable. You want to kind of use a predictive model to identify the persuadable voters. But that leaves you with a last mile problem. You need behavior augmentation. If somebody knocks on Jim's door and Jim says, yeah, okay, I'll vote for Obama, how do you persuade them to really go out there and vote? How can you get that guy to follow through? How do you get Jim to follow through? Well, one of the things the Obama campaign did was they used a very simple social nudge. They said, did you know that 90% of your neighbors in Santa Monica are going to go out and vote on election day? And the finding there, and this comes from Robert Cialdini, a very famous social psychologist, is that when people take an action, it's not necessarily because they think it's ethical or because they think it's economical. They just don't want to violate social norms. So, I know that voting is the right thing to do. And if the campaign worker says, Jim, voting is the right thing to do, wags his finger at me, I'll say, yeah, right, okay, fine. It won't really change my behavior. But if I learn that I'm one of the few people that doesn't vote, I kind of feel like that guy. I kind of feel like a jerk. So I don't want to feel like I'm violating the social norm. That's the finding. So that's one thing the Obama campaign did to kind of give a little social nudge. That was a compliment to the predictive model. The model tells you whose door to knock on. The social nudge helps you ensure that they will follow through and actually vote on election day. They did something else which is even more specific and very clever. They actually used something called a commitment device. In this case, it was a commitment card. And here's an image of one of the commitment cards. Yes, we can. The person fills out his name and his address, checks the box, and says, I'm going to sign this. Yes, I'm going to vote. And the premise is that, again, the psychological finding is that when people articulate a very specific plan to do something and really state it out loud, they're more likely to follow through than if they just get a tacit nod. So somehow, like, articulating it, put it in writing, being specific, forming a mental pathway, all those things, help ensure that people will actually follow through. These are very, very powerful ideas. It doesn't cost anything, or it costs very little, but these are experiments that you can run to say, is this an effective way to act on these model indications? So you can run A/B tests, you can do randomized controlled trials, you could use the commitment cards for half the people, not use them for the other half the people, and you can figure out, how effective are these commitment cards? So that's the idea of using behavioral nudge tactics. You use insights that come from the behavioral sciences, psychology, marketing, sociology, behavioral economics, and so on. And you don't just accept them on faith, you actually use them to design interventions, to motivate interventions. And I'm almost done. And then field test them. The hypothesis is that the commitment card will be efficacious, but we don't know, so we'll do a randomized control trial. So that's the other half of the coin. So that's sort of, in a nutshell, the science of behavioral insights. It's taking the public policy world by storm. The second annual behavioral exchange is happening in London in about a month from now. I was privileged to speak at the first one in Sydney last year. And, this is kind of like, people leave conferences like this as if they come from a rock concert. In public policy, this is a very exciting set of ideas for using science to help set more sensible public policies. This is what Rory Sutherland was saying. We're creating programs and policies designed for the brains of humans, not Vulcans, okay? I had an idea after this. I've built predictive models for the state of Pennsylvania, predicting which non-custodial parents, which usually divorced parents, are at highest risk of falling behind on the child support payments. And everybody was happy with this model. Everybody thinks it was worthwhile. It's saving money. It's keeping more pockets flowing to the children who need the money. But maybe commitment cards would also be an effective way to help non-custodial parents stay financially responsible and stick to their commitment. So maybe fusing behavioral insights on top of the predictive model indications would be an effective thing to do. OPower uses both data science and behavioral science. When they design utility bills, pointing out, Jim, you use 80% more energy than your neighbors in Santa Monica. And again, just like with the Obama example, that's more likely to get me to cut down on my power utilization than just a finger wagging thing or an economic argument. So they actually use data to help me figure out how can I save energy, but they also use social nudges to help me actually conserve the energy. They go that last mile. It's not just data, it's also behavioral science. An idea I had back when I wrote my article on corporate social responsibility with big data, I thought insurance companies, my old employers, could get involved in this. They can use this telematics data. Now that cars are part of the Internet of Things, right, the flow of data is so much different now. We're collecting all this very fine-grained detail about people's driving behaviors. Now, the traditional way of using that data is through better actuarial segmentation. Okay, that's fine. That's an economically efficient thing to do. It's actuarially fair. Okay, I'm not going to argue with that. But maybe there's something else we can do with the data. If the data is good, if the data can create risk scores telling the insurance company who's their safe driver, who's the unsafe driver, maybe you could take those risk scores and that fine-grained data and give feedback reports back to the drivers. And those feedback reports could be both intelligence augmentation and behavior augmentation. The feedback reports could tell people exactly how they can improve their driving and maybe also give them social nudges saying, you accelerate faster than 95% of people who are like you, my friend. You might want to think about that. And again, that's probably more likely to change my behavior than any number of warnings. Again, it's the Lake Wobegon effect. It's a famous result. The majority of drivers think they're better than average drivers. These kinds of telematics data enriched feedback reports would disabuse people of that notion. It would probably prompt safer driving. So this would be a socially responsible use of big data because it would be good for the driver. It would help the driver save money. It would be certainly good for the insurance company, and it would be good for society because we'd have safer roads. So this is an example of a non-big brother, I would claim, use of big data. Okay, I hope Sandy Penland would like that example. I think and one last example would be in the world. Another motivating example that kind of got me thinking about this area came from Atul Gawande's article, the hotspotters. You can use predictive models. It's quite straightforward to build a model to flag, say, the 5% of your health insureds who account for 60% of utilization. And that's what the Gini curve looks like. But again, what do you do about it? How can you get those people to change their behavior, to stay on their medications, to exercise, to comply with their treatment, and so on? How do you prompt that behavior change? Well, there are a lot of ideas out there. Clever uses of Fitbits might be one idea. Another idea would be health coaches for the most serious risks. That might be an interesting behavioral intervention. I won't go into detail about it unless somebody asks me during the Q&A, but read Atul Gawande's article, The Hotspotters, for some great stories on health coaches. So I think I'm going to end it there, okay? So if anybody has any questions, feel free to ask.
Great, Jim. Thank you very much for a thought-provoking presentation. The first question that came in really is trying to get at something that you alluded to, I think, in what might be described the potential for a darker side of this data revolution and the intersection of behavioral economics and data science, and that has to do with misuse of information.
Yeah.
And, a couple of examples that come to mind. One, a question that was specifically asked had to do with your comments about the prediction of future obesity and whether that sort of points toward, the comment was, it sounds like Minority Report.
Yeah.
Are there discrimination concerns if we decide on pre-crime statistics, who's likely to commit what crime? Or another example that you referred to was the expanding use in human resources of predictive analytics and who should be an employee or not, despite what the face-to-face interview might say. So if you could just comment on those aspects, that'd be great.
Yeah, no, I mean, I think the answers to some of those questions are almost so straightforward that they're almost rhetorical questions. I mean, the Minority Report question is absolutely spot on. I think the answer is yes with capital bold letters. Absolutely. I mean, you can imagine, like Sandy Penland was saying, you really want to watch how this data is used. And that's why Penland, in that comment, he said that issues of data privacy and also ownership were important. And ownership is an interesting comment. Richard Thaler, another, my other hero in this story, he's written some very interesting things more recently that's not even in his book Misbehaving. It's sort of what he's thinking about now. New models of data ownership. This might be pie in the sky, but Thaler's actually trying to influence legislation. His idea is that he's an efficient market theorist, right? He's working at a libertarian university. He's a libertarian in a lot of ways. And he says, imagine a world where anytime an organization, be it a company or a government agency, collects data about you, about your eating behavior, your movie watching behavior, all this kind of stuff. The premise is that data is yours, and you're lending it to that organization. And so anytime you want that data, according to his proposed legislation, the company or the government agency should be required to provide you that information in machine-readable format at the click of a button. And the idea is that you can, this could be your data about your mobile phone usage or your, supermarket club card shopping data or your movie watching data, whatever it is. Well, in the mobile phone example, you could take that data and you could upload that into a website that would be called, cellphones.com. And it could be like the Kayak or the TripAdvisor for cell phones. Based on your mobile phone usage, here's the carrier and here's the plan that's right for you, right? So rather than trying to, take advantage of human frailties, which is nobody can, even a Nobel Prize winning economist can't figure out all the footnotes of a mobile phone bill agreement. Here's a very simple situation. Here's a very simple solution that would kind of use data to help people make better decisions, not exploit their human frailties. You can also imagine that data being used, if people own their own data, they could choose to use they could choose how it's used. So like, if I have Fitbit data, if I keep track of how much I sleep at night, if I'm keeping track of, the food I'm buying, how much time am I spending watching TV, that's also a predictor. If I had all that data available, I could decide who I share that data with. Again, I'm sort of speculating here. So I'm not saying I have the answers because I don't. All I'm saying is that thinking about new models of data ownership, who owns the data, Jerome Lanier wrote a book called Who Owns the Future, maybe part of the answer lies there. I came across those ideas after I wrote my article. My article is called The Personalized and the Personal. I really wanted to focus on this area about socially responsible uses of data. In the absence of those kind of broad reforms that people like Thaler and Pentland has a scheme called New Deal on Data. In the absence of those kinds of large-scale societal governmental reforms, I just think it's incumbent upon government agencies and businesses to entertain socially responsible uses of data. Just think in the long term, not in the short term. Think of what uses of big data really are going to fly. Would you be happy telling your mother about it? That's all I have to say. It's not an answer, but I hope it's something.
Okay, great. Thank you. Another question from David Dietrich. Well, first, there was a question about whether this presentation will be made available, which it will be on the NCDS website. But the more specific question reads as follows: sharing feedback from the telematics example or energy usage examples. Both give feedback to someone about how they fare to establish social norms. This is great to nudge those who are laggards, high energy users, who could reduce their usage, for example. But I recall from Thaler, I think, that it could be dangerous or counterproductive to tell people their usage is great.
Yeah,
for instance,
totally.
As many people then relax and revert to the social norm of good for energy usage. Can you comment on this or suggest on how that might be mitigated?
Yes, and so it's a smart question. A second comment is going back to the social responsibility theme. This is different from the question, but it's still important. You could lie. You could just tell people whatever you want to tell them and nudge them based on a lie. You don't want to do that because it would be unethical. So like any other technology, behavioral nudges and data science can be used ethically or unethically. But for the specific question, that's a very smart question. But I think in behavioral science, they call that the boomerang effect. So if O-Power sends me a letter saying, Jim, you're actually one of the best utilizers in Santa Monica, then I'm like, oh, great, turn that air conditioning up. Oh, great, I'll accelerate my new Volkswagen GTI, fine. And that's called boomerang effect, if I'm better than average. And so what they did is they experimented with a second nudge. For the people who are on the good end of that bell curve, they used what they call a reciprocity effect. They said, congratulations, you're one of the 10% best people, smiley face. And it gives you this little pat on the back, and then you want to turn into the good student. You want to kind of keep pleasing the teacher. And so what they found was that when they used that little reciprocity effect, that was a second nudge, and that actually took away the boomerang effect. So again, I don't want to make it seem like there's some nudge for everything. There's an app for that. I mean, I don't think it's that straightforward, but it's a very nice story, and it's a case where, you uncover a problem like that, and you can come up with a clever solution. And I think the point is not that there's an answer for everything, but it's more like this is a new wellspring of ideas. It's a very exciting area to explore and really take data analytics to the next level.
Great, excellent. A question came in about tools that you regularly use, technologies, platforms in your predictive analytics work or modeling, or things that you're particularly excited about as you look towards the future.
Sure. So for me, it's always been, just one letter, young man, R. I've been using R since 2003. It's open source. I've always described it as the Wikipedia of statistics. It's a great tool for learning. It was designed at Bell Labs, or the original language was designed at Bell Labs to kind of promote interacting with data, exploring data, this kind of idea of greater statistics, which is everything about learning from data. So it promotes like a very intelligent, in-control analysis of data as opposed to kind of like a rote procedural approach to data analysis or push-button statistics approach, which I'm a little bit less keen on. Now, I started using SAS. I started adopting R in 2003 because it has excellent data visualization. It's open source. It has everything in it. It's written by statisticians to conform to the way statisticians think. So it's just like a great tool for thinking about things, and it makes you smarter. It's designed with like Roy Sullivan was saying, it was designed for the mind of human data scientists. There are a lot of new tools out there that a lot of my colleagues at Deloitte are using: Python, IPython notebooks, D3 for interactive data visualization. For people who are less, heavy-duty quants, Tableau and QlikView are examples of tools that are very easy to use and can really do very nice data visualizations. So those are all examples of tools. So open source has actually become a big part of the data science movement, which is a very, very nice thing. A lot of open data and a lot of open source software.
Excellent. Good. Well, thank you. And additional questions that people have, maybe you didn't get a chance to get them aired today, you can email them to info@data2discovery.org, and we'll make sure they get back to Jim, and we can get a reply on that. But Jim, thank you very much for presenting this talk today. We appreciate your time and that of our audience, our attendees. For those of you in the audience, remember that DataBytes is a monthly webinar series, and our next session is scheduled for Wednesday, September the 9th at noon, and we'll feature one of our NCDS data fellows, David Guszcza, who's a faculty member at the UNC Chapel Hill School of Information and Library Science, and he'll be highlighting his work on visual analytics for large-scale temporal event data. We hope you will join us. Jim, thank you again for your time and for your presentation, and thank you, everyone, for your attendance today. We greatly appreciate it.
Thank you.